Astronomers have long been watching one of the brightest, most enigmatic stars in the night sky. Betelgeuse, a red supergiant on the edge of crumbling. They stated that it was coming. Their only uncertainty was when now the James Webb Space Telescope has captured something that no one believed we would ever see. The moment Betelgeuse began to explode, cosmic shock, a dying star. A wave and a glimpse into the undiluted power of the universe. This isn't just another observation from deep space. This is a once-in-a-lifetime occasion, the nearest supernova ever observed by humans. And Webb's observations have changed everything. Betelgeuse, which can be found in the shoulder of the Orion constellation, is unlike any other star. It is more than just a red supergiant, 700 times larger than our Sun and roughly 20 times as massive. For decades, scientists have known it was unstable, swelling, dimming, erupting. It suddenly dimmed in 2019, triggering worldwide speculation. Was this the moment? Was it exploding into space? Now, with the precision of the Webb telescope, the mystery has grown. For the first time, we are observing indicators in real time: massive energy collapse of stellar layers, shifting surface convection, discharges, and the chaotic twisting of magnetic fields. Betelgeuse isn't just dying, it's transforming right before our eyes. The James Webb Space Telescope has been focused for months on Betelgeuse, using its infrared vision to peer into layers no previous observatory could penetrate. And now, the data is in. What it shows is stunning. We can see convective bubbles the size of Jupiter bursting on the surface. We can follow hot gas plumes exploding into space at incredible speed, and concealed from view in the visible spectrum, a signature shockwave is moving through the outer layers of the star. For the first time ever, astronomers are observing the actual physics of a star separating from itself. This isn't a simulation. It's the real-time anatomy of a supernova. And it's taking place just 642 light-years from Earth, in contrast to other supernovae that occur in distant galaxies. Betelgeuse is close. Cosmically speaking, its explosion may become so bright that it could be visible during the day, brighter than the full moon. But more importantly, its proximity gives scientists a once-in-a-generation chance to study the close-up death of a star, how its very core collapses, how elements like carbon and oxygen are forged, and how the shockwave transforms the space around it. What Webb captured isn't just a star dying. It's the very process that results in the building blocks of life, the same components that gave rise to Earth. And to us, we are looking back at our cosmic ancestry. The explosion of Betelgeuse is more than just spectacle. It's a key, unlocking the processes behind galaxy formation, planetary systems, and the cycle of life in the universe. Through Webb's cutting-edge tools, we can now model the final stages of stellar evolution with unparalleled accuracy. We can comprehend what takes place inside a dying star, and we may even learn what signals to look for in others, possibly predicting future supernova long before they happen. This is not just science. It's a moment when humankind stared into the abyss of time, unsaw light explode back. Betelgeuse's explosion is not a one-time event. It sends shockwaves across vast distances, disturbing the surrounding interstellar medium. Webb has already identified the early ripples, high-energy particles moving outward, heating nearby gas clouds and altering the shape of the star's dust halo. But there's something else, a gravitational shift, even from 642 light-years away. The collapse of Betelgeuse's core may have sent out gravitational waves, the kind we have only recently begun to detect. If confirmed, this would be the first time a directly visible supernova is linked with gravitational data that would rewrite everything we know about the interaction of light, matter, and speed. Talus collapses. One of the most pressing cosmic questions returns. What remains? A neutron star, a black hole, or something else? Data from Webb suggests Betelgeuse's collapse may not be entirely uniform. There are magnetic plasma voids, field disruptions, and a possible asymmetric fallback where material doesn't escape into space, but is dragged back in. Some speculative astrophysicists are already theorizing about a transitional object, a phenomenon that persists somewhere between the known and the unknown. Within a neutron-theorized star and black hole but never observed if, the Webb has detected this. Action is warranted, since it would be the initial direct sign of a new kind of cosmic object, with only 642 light-years between us and the stars. Explosion, many have inquired, are we in danger? The quick response is no, Betelgeuse is not dangerously close to Earth, but the longer answer is more complex. A wave will be released by the explosion, a wave of high-energy particles, gamma, rays and expanding electromagnetic radiation bursts. These have the potential to disrupt clouds of cosmic dust that influence other star systems, and even change the way we receive light from distant places. For now, Webb is closely monitoring the speed and distribution of this radiation front, because despite our safety, the explosion may alter the optical structure of our galactic neighborhood, changing our perspective on the universe from this point. On Betelgeuse is enormous, old, powerful, but it is failing. A reminder that even stars, those eternal lights in our sky, are limited. What Webb captured is more than just a star dying. It's a cosmic mirror held up to us. Everything that lives ends. However, in that end, new components emerge. New stars will rise from the ashes of Betelgeuse. New worlds may form in the chaos it leaves behind. There is no devastation. Here, this is cosmic rebirth, and we were fortunate enough to witness it. From the vast amount of data collected by the James Webb Telescope, scientists discovered an unexpected fact: variations in the composition of the elements in the ejected debris. The explosion of Betelgeuse is releasing not only carbon, oxygen, and iron, but rare elements like yttrium and technetium, formed only in supersonic environments. Why is this significant? Because analyzing the ratios of these elements allows researchers to trace the life cycle of matter in our galaxy, from the core of dying stars to the dust that creates planets, to the atoms that make up you and me. Webb is more than just recording the explosion. It's decoding the chemical script of how life can be lived. And in its final moments, Betelgeuse is telling a story that started long before Earth was real. Betelgeuse won't come back. Its location will evolve into an expanding cloud of gas, superheated and glowing debris in Orion. But its death isn't an end. It's a gift of knowledge, of elements, of perspective. It reminds us that our sun, too, will eventually vanish. It's just like the most brilliant lights in the sky. It will have a final scene. However, this conclusion contains the blueprint for everything. New dot, because without supernova, there are no oceans, no planets, and no life. And now we have the James Webb Telescope. We can finally observe the entire cycle, from the fiery depletion of basic materials to the rebirth of cosmic order. 642 light-years sat in the cold silence of space. A star's life ended not with a whisper, but with a roar. A brilliant last roar that traveled through the darkness for hundreds of years until it reached us. Greetings from the James Webb Space Telescope. We didn't just see it, we understood it. We saw the signs, the collapse, the detonation. Myth as fact. Not a metaphor. Betelgeuse didn't die in vain. In its final moment, it gave us answers to questions that date back before humanity itself. Where do the elements originate? How do stars ever exist? What will happen to our own sun? In that dying shade of red light, Webb has captured more than a supernova. It has accurately portrayed our genesis as well as a glimpse of our future. So we must ask ourselves, what else? Is the universe prepared to tell us? And are we truly ready to observe it? Let us know what you think in the comments. Was this the most significant astronomical event of our time? And what will be the next cosmic secret the James Webb Telescope reveals? Subscribe and enable notifications, because this is far from over. It marks the beginning of what follows the stars.